There we go, 1 second late. Anyway, this is Tech Math 2, and we're going to do chapter 13.1 and 13.2 today. And so that means we're going to revisit sines and cosines. We already did a thing where I have theta, and I got the hypotenuse, if I could spell hypotenuse, and I have the adjacent side, ADJ, and I have the opposite side, and we said sine of theta, if I could write theta, is the opposite over the hypotenuse. Okay, so we already did that once, and then we did it another time, and this is our third time through. And the third time through, we're using, if I could spell hypotenuse, oh, much better. And the Greeks gave us that word. What we're going to do is we're going to use we're going to use an XY plane again. So we got an XY plane. We have some distance r, and we have some point x and y. And we're going to define. Okay, so there's my x and there's my y. And we're going to define our sine function as y over r. And our cosine function, we'll throw in a theta there just to protect the innocent. And the cosine of theta, x over r. And the tangent of theta, y over x. And then we can go, we can have the cosecant, which is 1 over the sine, and that's going to be r over y. But y can't be 0, because if y is 0, that'd be bad. Now, we normally don't say r can't be 0, because if r were 0, we wouldn't have an angle. So we normally don't say that for cosine and sine in this particular application. Sine, cosecant. So the cosecant is 1 over the cosine, so I'd have r over x. And then I'd say, well, I can't let x be 0, because that won't, that's not good. I can't divide by 0. And then the cotangent, x over y. Y can't be 0. And I'd come back to this guy and say x can't be 0 when I had the x on the bottom either. Okay, so those are all the things that we know. And we also have another one that says the tangent of theta is the same as the sine divided by the cosine. Well, let's say tangent is y over x, right? Y over x. And the sine is y over r, and the cosine is x over r. And the r's go away, and all we have is y over x. So I guess that's probably the case. And I'm turning the page to 448. And I find that if I have the sine squared, and I have the, well, normally we put this in alphabetical order. The author doesn't have it in alphabetical order for some reason. Cosine squared plus sine squared is 1. So it doesn't matter. Now, why would that be true? Why would the cosine, why does it always have to be 1? Well, if I have some point, so there's some point, there's the x, there's the y. X is, the cosine guy is doing this, the sine guy is doing that. Well, that was really bad, wasn't it? But if I look at a right triangle, see if I can put it in the right spot. So if I look at that right triangle, and I say, well, if r were 1, it really doesn't matter if r is 1, or over here and r is 2, or over there where r is 3. It could be, but r could be 1. If r was 1, then this side's x and that side's y. And if I do cosine squared, so I'd have x over 1 squared plus y over 1 squared is equal to 1. Well, this is Pythagorean theorem. X squared plus y squared is 1 squared. Well, I don't say squared on the 1. I just leave it off because 1 squared and 1 is the same thing. So just leave it that way. So that's why sine squared and cosine squared plus cosine squared is always 1. There's nothing I can do about it. And then I can go and throw in, I can divide both sides by cosine, for example. And if I did, I'd have 1 plus the tangent squared is equal to 1 over cosine, which would be secant. So that'd be secant theta squared. And I can divide it by sine. So if I had sine squared, so if I divide it by sine squared, I'd have cotangent squared theta plus 1 is equal to cosecant. So cosecant squared theta. So those are two other formulas that derive directly from cosine squared plus sine squared is 1. All right. So now we're going to look at something else. This is the unit circle, and let's see if I can get it small enough so we can see the whole thing. Of course, if we no, we can't. It's that size. So this shows us that in the first quadrant, at 30 degrees, the cosine is square root of 3 over 2. At 45 degrees, the cosine is square root of 2 over 2. And at 60 degrees, it's a half. It shows us that the sine at 30 is a half, the sine of 45 square root of 2 over 2, the sine of 60 is square root of 3 over 2. And it shows that in all 4 quadrants. And so there's something that can be printed out and memorized if you want to do that. But that's basically how I think about things most of the time anyway. And it's not in the front or back of your book. But so if you haven't seen the unit circle before, there it is, because I don't think I showed it to you before. And that's why I go 5 pi over 6 is 150 degrees. Those guys come together there. Okay, enough of that. But now it's in the notes, so it has to be true. If I have something over here is equal to something over here, and I want to show that it's right. I want to show that the equal sign is true. That's what I want to do. Well, how am I going to do that? Well, what I'm going to do is I'm going to manipulate this side until it becomes the same thing that I have over on the other side. Or if it's simpler, I'm going to manipulate the right-hand side until it becomes what's on the left-hand side. But in trig identity solving, I normally don't do something to both sides, because if I do something to both sides, I have changed the equation, and I'm not showing that it's what it's supposed to be. Okay, so that's just one of those things. All right, so I'm going to do problem number 2 first. And I'm going to show that 1 over the tangent of theta is equal to the cotangent of theta. Well, gee, I guess I'm done. Well, no. What we would do is we'd take one side of the equation and say, well, that's 1 divided by sine theta divided by cosine theta. Is that the same as the cotangent? I don't know yet. And then I'd invert and multiply, call that cosine theta divided by sine theta. And is that equal to cotangent theta? And the answer is yes, check. And we could have just said check there too, because that's our definition. 1 over tangent is cotangent. But what we're supposed to be doing is changing one side of the equation so that we equal the other side of the equation. We're already there. Yeah, we'll move on. We'll do 8. So I've got cosecant x, tangent x is supposed to be secant x. All right, well, I'll change the cosecant to 1 over sine. And I'll change the tangent to sine over cosine. And then I'll say, oh, I got one there, I got one there. Isn't that convenient? Now I've got 1 over cosine x, which by definition is the secant x. And Ben's not here yet, so that's why he didn't tell me I misspelled secant up here. So I'll go and spell that right. All right, we'll look at number 9 next. Yeah, spelling is relatively important, especially if you're in English class. But oh, this isn't an English class. Divided by secant. Which is more important, spelling or the correct answer? Anyway, I don't know. Could be. Cotangent theta. All right, so I'm going to change everything on the left-hand side to sines and cosines. 1 over sine divided by 1 over cosine is supposed to equal cotangent. All right, I'm going to invert and multiply. Cosine divided by sine is supposed to be cotangent. Oh, wait a minute, it is cotangent. Oh, done. All right. That's 18. We'll move on to 18. One plus the tangent squared of x times the sine squared of x is supposed to equal the tangent squared of x. Well, 1 plus tangent, we remember, we turn our page over, we look in front of the book or do something, and we remember that 1 plus tangent is going to be secant. So this is secant squared x times sine x. Sine squared x. And secant squared is 1 over cosine squared times sine squared x. And that's supposed to equal tangent squared x. We don't know that yet. And then we got sine x over cosine x quantity squared. And we, oh, that is tangent. All right, so this is equal to tangent squared x. And we're done. And I really did take too many steps there, but, oh, I guess not. It all fills the screen, so I didn't do that many steps. Okay, moving on to 28. Am I going fast enough? 28. Anybody bored yet? Sine squared theta minus cosine squared theta. It's supposed to equal 1 minus 2 cosine squared theta. Now we have a choice. We can either do it on the right-hand side or do it on the left-hand side. Those are our choices. But we remember, do we remember, that sine squared plus cosine squared is 1, right? So that means that sine squared has to be 1 minus cosine. All right, so like I said, this is 1 minus cosine squared minus cosine squared. So when theta is to intersect the inviscid. And then we'll say that, well, that's 1 minus 2 cosine squared theta is supposed to equal 1 minus 2 cosine squared theta, and it does. So that means we are done. We have shown that those two identities are the same. All right, we'll move down to 40. I can't imagine any good reason to do 40. But we'll do 40 anyway. I'm not sure I can write 40 and have it fit on the screen. All right, so I got secant x tangent x sine x. And they're all added together. It's supposed to be 1 plus sine plus sine times cosine divided by cosine. Okay, well, I guess that's all right. All right, so secant is 1 over cosine. And tangent is sine over cosine. And sine is sine x. And then I say, well, I need a common denominator. Because if I'm going to add these guys together, I'm going to have a common denominator. So I'll multiply both sides by cosine x. And then I'm going to have 1 plus sine x plus sine x cosine x divided by cosine x. Say it's not so. We're done already. Are we done already? We're done already. What a bummer. All right. We'll do 50. These are much too easy. We're going to have to move on to the next section so that we can have something worthwhile. The secant to the 4th power minus 1 is supposed to be the tangent squared x times secant squared x plus 1. Okay, well, what are we going to do about that? Well, I find that secant squared is equal to 1 plus tangent squared. So if we go and replace this guy with 1 plus tangent x squared minus 1, then that would be a good starting point, I think. Now, the thing of it is that if you get to a dead end and you can't go anywhere, just erase your paper and start over again. All right, so I'm going to square this guy. 1 plus 2 tangent squared x, no, plus 2 tangent, plus tangent squared x minus 1. Oh, that's not right, because this is a square here. That has to be a square there. That's a 4th power there. Okay. And that's supposed to equal this guy over here. Okay, so that looks good. Okay, so now I've got 1 and a minus 1. So I got a 2 tangent squared x. That's a plus sign. Doesn't look like a plus sign, does it? Plus I don't know if I want to do that because I got this tangent x out here. I'm gonna factor out a tangent x. So I got tangent squared x times 2 plus tangent squared x. And that's supposed to equal what I have over there. Well, we'll see about this. All right, now, tangent squared x, I come back up to this guy and I see that tangent squared x is secant squared minus 1. Okay, so I'm going to come down here and say tangent squared x times 2 plus secant squared x minus 1 is supposed to equal what's on the other side of the equation. All right, and then, oh, I got a 2 and I got a minus 1, so I got tangent squared x times 1 plus secant squared x. And I have it on pretty good authority that that's what we're trying to find, right? Yeah, that's what we're trying to find. So we'll give it a check, and we'll make this guy look like an equal sign. All right, now we'll do number 54. Number 54. And move on. Okay, so I've got tangent theta, and I've got secant minus cosine. Really? Secant minus cosine. And I want him to equal cosecant. That's what I want. All right, so I'm going to change everything on the left-hand side to sines and cosines. I got sine over cosine divided by 1 over cosine minus cosine. Okay, well, that is interesting. Okay, I'm going to multiply top and bottom by cosine. So I've got sine divided by nothing. Yeah, because I get a 1 there. Okay, so that goes away. And then I get a 1 minus cosine squared theta. Okay, so what the heck is that? Okay, well, we remember that sine squared plus cosine squared is 1. So 1 minus cosine squared has to be sine squared. So this is sine theta over sine squared theta. And now I got 1 over sine. And 1 over sine is, in fact, the cosecant. I'm certainly hoping I'm supposed to be looking for the cosecant. Tell me I was looking for the cosecant. Yes, I was. Okay. Because if I wasn't, it's going to be a very long day. Okay, questions about solving trig identities? Yeah, other than I don't want to do it. That doesn't count. All right, so Now we're in section 13.2, and we have a bunch of more formulas. Now, all these formulas in 13.2 are in the back cover of your book, and on any test or quiz, the back cover of your book and the front cover of your book are perfectly okay. Have them open and look. All right, so if, and I don't remember these, I have to look them up too. Sine of theta plus phi. Okay, sine of theta plus phi, sine, cosine plus cosine, sine. Sine, cosine plus cosine, sine. Theta, phi. Theta, phi. All right, and if I have the cosine of theta plus phi, I'm going to have cosine, cosine, sine, sine, cosine, cosine minus sine, sine, phi, theta, phi, theta. Right.
What is that last second one? You got theta and phi?
Theta, phi, yeah. That's the Greek letter phi, as in phi, phi, pho, phum.
Just making sure.
Yeah, phi. Notice I didn't spell phi. Now, if you're at a four-year school and you're going to some fraternity, then one of the things you'd have to do is probably recite the Greek alphabet backwards, and then you'd know all the Greek symbols, and it wouldn't be a problem, and everything else would be wonderful for you. You'd learn how to drink beer properly, you know, things like that. Well, you don't use a cup to drink beer, you know. Use mugs and you know, the spigot. You don't just use the spigot. All right, now we have two other things sitting here. So we have the sine of minus phi is minus sine phi, and we have the cosine of minus theta. That's a theta. I remember that is equal to the cosine theta. Now that begs the issue: if I have a function where the function of minus x is equal to minus the function at x, we call that an odd function. Okay, and if we have a function at minus x is equal to the function at x, we call that an even function. So sine is an odd function, and theta is and cosine is an even function. Now, the math goes deeper than that, because the series approximation of sine, so I have sine x, is going to be x minus x squared, x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 6th, x to the 7th over 7 factorial. You see a pattern yet? Blah, blah, blah. And then the cosine of x is equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And now you can see that sine is odd because all their exponents is odd. Cosine is even because all the exponents are even. We don't do this until chapter 28, I think, is where we learn that the series of approximations for sines and cosines. But when you take your calculator and you ask it for the sine of some number, it doesn't look it up in some table. It does this series approximation out to 10 or so places, and that's plenty of significant digits for you, and get back the answer. And we'll show that too when we get to that chapter. Okay, well anyway, even and odd functions On page 544, we see tangent is odd, cotangent is odd, secant is even, and cosecant is odd. Isn't that lovely? I'm sure no one will ever ask you that again, but that's beside the point. Okay, now we have the rest of the, we still have other things. Okay, so we have the sine of theta minus phi. And we have the cosine of theta minus phi. And we have the tangent of theta plus phi. And we have the tangent of theta minus phi. And then with that, we're done with all the identities that we're going to deal with in this section. There's still more to go, but we won't have to worry about them until tomorrow. Tomorrow? Oh well, that's just the way it is. So let's see, we have sine, cosine, sine, cosine, minus cosine, sine, and theta, phi, theta. I think I had to memorize these in 10th grade. I think I did. And then we got cosine, cosine, plus sine, sine, theta, phi, theta, wait a minute, phi, theta, whatever it is, the first one and the second one. And then the tangent guys are funnier. So I have tangent theta plus tangent phi divided by 1 minus tangent theta tangent phi. Now we never ask you to prove these identities. I think I had to do that in college, but maybe I didn't. That was a long time ago. Tangent theta minus tangent phi, the other phi, divided by 1 plus. 1 plus. So whenever you're working these problems, make sure you go back to the front cover, the back cover, and you get the right identity and you write it down right. Otherwise, you're just going to be not getting the right answer, and that's ridiculous, right? Because it's much too easy. If any 10th grader can do it, you guys can do it too, right? All right, so we're going to look at number 1. And we're going to look at the sine of x plus pi. And we're going to practice what we preach, and we'll turn the page over and look at the plus sine guy. And he looks like sine, cosine, plus cosine, sine. So he's going to look like sine, cosine, plus cosine, sine, and x, pi, x, pi, and the sine at pi is 0, and the cosine at pi is minus 1, and this is going to be equal to minus sine x. Is that what I'm supposed to get? Yes, I'm supposed to get it. Boom, done. And we'll move down to number 2. And we're supposed to show number 3. My mistake. Number 3, we have sine x plus 2 pi. And we're supposed to show that that's sine x. Okay, well that's fine. And we remember, because we just did it, that this is sine times cosine plus cosine times sine, and we have an x, and we have a 2 pi, and we have a x, and we have a 2 pi, and we remember that the sine of 2 pi is 0, and the cosine of 2 pi is 1, and this is going to be equal to the sine x. Check. Okay. We'll try, we won't try, we'll do number 8. That'd be good. All right, number 8. The cosine of pi over 2, also known as 90 degrees, if anybody is wondering, minus theta. Okay, and we want this to be sine theta. And if we can't make it sine theta, then what good are we? All right, so we want the minus the cosine. So minus the cosine is going to be cosine plus sine sine. All right, so cosine, sine, sine. Oh, that doesn't look good, does it? Okay, so this is pi over 2, and this is v. And this is pi over 2, and this is theta. And that's good. Excellent. Notice that I'm not bringing the negative sign with me. That's not negative theta. Okay, it's just theta because I'm using a trig identity. Okay, so that being the case, cosine of 90 degrees is 0, sine of 90 degrees is 1, and I end up with sine theta, which is what I'm supposed to end up with, so I am done with that guy. Oh, okay, we'll do
Why don't we create cosine? of
What?
theta? It's just sine theta plus cosine theta if you take out.
0 times.
Okay, oh, that's right. Okay.
So I'm using formula 21, which says the difference of two angles, the cosine of the difference of two angles is cosine plus sine sine. That's what I'm doing. And then I'm figuring out what that is. Yeah, exactly. Well, not exactly, but to the first approximation. And maybe I'm getting it right. You know, that could be too. Well, unfortunately, I'd have to turn the page to get that one, so I'll do 14 first. Okay, so I have the sine of pi over 3 plus theta. All right, well, I forgot what this guy is already, so I'll turn it over to the other side. It's sine cosine plus cosine sine. So I got sine cosine plus cosine sine. All right, well, I didn't write down what I'm looking for, so that could be bad news. The sine of 60 degrees is the square root of 3 over 2. So I got the square root of 3 over 2 cosine theta plus the cosine of 60 degrees is 1/2 sine theta. Okay. All right, well, I'll just put it out under a common denominator. Square root of, looking at what I'm looking for, cosine theta plus sine theta divided by 2, and lo and behold, that's exactly what I'm looking for, so I am done. All right, now we can do 15. Anybody want to go to the board and do 15 for me? Yeah, typical. Number 15. Someday someone's going to take me up on it and spend the rest of the class period doing number 15. And you're going to wonder what a class period was. Okay, so the tangent of 90 degrees minus x. The tangent of 90 degrees minus x. Wait a minute, the tangent of 90 degrees is infinity. Wow. This could be interesting. And it's supposed to equal to the cotangent of x. Okay, so that's what we're supposed to be getting. Okay, well, the tangent minus. Okay, so that's going to be tangent of 90 minus tangent x divided by 1 plus tangent 90 times tangent x. Now, the problem with that is that tangent 90 is undefined, right? The tangent function does this, and at 90 degrees, it's over there at infinity, and it's undefined. So how am I going to figure that guy out anyway? So what should we do? Okay, we're going to multiply top and bottom by 1 over tangent. Okay, so I'm going to go 1 over tangent. We're going to ignore the fact that I'm dividing by 0. How's that? Ignore the fact that that tangent 90 is undefined, and just multiply top and bottom by 1 over tangent 90. All right, so if we do that, we're going to get 1 minus tangent x over tangent 90 divided by 1 over tangent 90 plus tangent x. Okay, now nothing up my sleeve, everything's fine so far? Okay, so I'm okay. Now, this is where we get sneaky. What's 1 over infinity? 0. What's tangent x over infinity? 0. 1 over tangent x. Well, I got rid of the pesky tangent 90 guy, and I also came up with the cotangent of x as my answer, which is what I was looking for. Oh, well, that was convenient. You know, so, yeah, we could do this forever. Okay, let's try 20. That was 15? Okay, we'll do 20. Number 20. I got the sine x plus y times the sine of x minus y. And I'm supposed to have sine squared minus sine squared. Okay, that's what I'm supposed to have. Okay, so sine of x minus y is sine x cosine y. Sine x cosine y plus cosine x sine y. And the sine of x minus y, sine of x minus y is sine cosine sine x cosine y minus cosine x sine y. All right, so I did that. Now, I recognize this as x plus y times x minus y. And x plus y times x minus y is going to be x squared plus minus y squared, right? So that's what I'm going to apply to what I see there. So I've got sine x cosine y squared minus cosine x sine y squared. Okay, so that was convenient that we did chapter 1 first, or whatever chapter 2, I guess, where we learned the difference of two squares. All right, so that's probably the only reason the problem's there, so we can remember that. All right, so now I've got sine squared x cosine squared y minus cosine squared x sine squared y. Now what am I going to do? What am I supposed to be getting anyway? I'm supposed to be getting sine minus cosine, right? No, sine minus sine. Okay. So I want to get rid of the cosine terms. Okay, I can say sine squared x times 1 minus sine squared y minus 1 minus sine squared x times sine squared y. All right, now I got rid of the cosine guys. All right, so now I've got sine squared x minus sine to the 4th. No, not sine to the 4th. Sine to the 4th. Sine squared x sine squared y. And then I've got minus sine squared y minus sine squared x sine squared y. Oh, isn't that convenient? So I got minus sine squared x sine squared y, and I've got plus sine squared x sine squared y. They go away, and all I have left is sine squared x minus sine squared y, which is what we're looking for. Yes. Uh-oh. 1 minute to go. I have to do 32 in 1 minute. All right. Luckily, you don't have anything after this class, right? So we can stay longer. Cosine, no, you have a lab after this class. A plus B. Cosine B. Cosine B plus sine but it's not equal to anything. What are we supposed to do? Oh, we're just simplifying. Oh, no problem. A plus B sine B. Okay, so I've got cosine, cosine plus sine, sine. I look for cosine, cosine plus sine, sine. I see that that is the cosine guy. The cosine of A plus B minus B. So this whole thing is just cosine A. Final answer. And, 5 seconds to spare. Yes. What? Ben's giving me one of those.
You're good.
What? You don't see how I did that?
No, you're good.
Do you see it now?
Yeah.
I just recognize cosine, cosine, plus sine, sine is that identity. That's the theta. That's the phi. Yeah. That's all there is. There ain't no more.